Okay, so we're going to start our next unit, which is light and color. This is a fun unit. It's going to be a short unit, but it's fun. Talking about light and how we see color. Light is actually really weird. When we start talking about light and how it behaves on a quantum level, it is actually very interesting. So we've been studying light for over 2,000 years. The nature of light has laid the foundation for quantum mechanics. By studying light, we've been able to develop technologies such as monitors, fiber optic cables, and quantum computers. Now, we call that waves travel in different ways. So a transverse wave is a wave that vibrates at right angles to the direction of travel. So if it vibrates up and down, it travels left to right. A longitudinal wave vibrates in the same direction as it travels. So, for example, a wave vibrates left to right and moves left to right. So let's review. What is a wave? Well, a wave is a disturbance or vibration that transfers energy. Recall that there was two different types of waves. There was mechanical wave that requires a medium or matter to transfer energy, such as air, water, those types of mediums, and electromagnetic waves that do not require a medium, so they travel through empty space. And in this unit, we're going to focus on electromagnetic waves. So, what is light? Well, light is a transverse electromagnetic wave. Light is part of the electromagnetic spectrum. So, light is a transverse electromagnetic wave. So, transverse meaning that it propagates at right angles to the direction that it's moving. And light is part of the electromagnetic spectrum. Well, what is the electromagnetic spectrum? Well, good question. That is a series of different types of electromagnetic waves. So there are 7 of them: radio, microwave, infrared, visible light, ultraviolet, X-rays, and gamma rays. These are the 7 types of electromagnetic waves. So, for example, you have radio, microwaves, infrared, which transfers heat, visible light, ultraviolet, X-rays, and gamma rays. And the wavelength is shorter as you go from radio to gamma rays. So, electromagnetic radiation. Well, waves transfer energy. So, electromagnetic radiation is the energy of the electromagnetic wave. So, there are certain patterns to the electromagnetic spectrum. You have the longest wavelength and lowest energy and the lowest frequency on the radio side, and as you go from left to right, you gain energy, you have higher frequency, and you have a shorter wavelength. Remember that wavelength and frequency are inverse. So as you increase the wavelength, the frequency decreases. And then visible light is broken up to 7 main colors: red, orange, yellow, green, blue, indigo, and violet. So red has the longest wavelength because it's on the leftmost side. Orange is the second. Blue, indigo, violet have the shortest wavelengths of color of visible light. So based on our pattern, we can see that red has less energy than violet, for example. So red light has the least amount of energy. Now, a lot of people are posting online, I see, in a lot of news sites and a lot of conspiracy theories saying that 5G, the new cell phone radiation, causes cancer. Let me ask you this. So, 5G is actually within the radio wave spectrum. So that has the least amount of energy. in order to cause cancer, it has to be ionizing, and ionizing doesn't start about midway through the ultraviolet spectrum. So therefore, it is clear that 5G does not cause cancer. And if 5G causes cancer, that means that light bulbs cause cancer because we see light. Visible light is the light we see, so every time you turn on a light bulb, you'll be getting cancer if 5G causes cancer. Also, if 5G causes cancer, then infrared light will cause cancer. And as humans, as anything that gives off heat, we will be getting our cancer, but we don't. So if anyone who tells you that 5G causes cancer, tell them that they're wrong, because 5G radiation does not cause cancer. A little side note there. So we talked about patterns. Once again, that radio waves have the longest wavelength, but the lowest frequency. Gamma rays have the shortest wavelength, but the highest frequency. And all electromagnetic waves travel at the same speed. This is very important. All electromagnetic waves travel at the same speed. So a radio wave travels at the same speed as a gamma ray. They all travel at the same speed. In fact, one thing I did not mention, however, that light travels at the same speed no matter how fast you go relative to the observer. And this is the foundation of Einstein's theory of relativity, which we'll talk more about when we talk about modern physics. But radio, microwave, infrared, visible light, ultraviolet, X-rays, gamma, they're all types of light. This is all light. These are different types of photons. Right? Radio waves are a form of light. I know we think about light as being visible light, but microwaves are light, infrared are light, X-rays are light, gamma rays are light, radio waves are light. These are all different types of light. So, an easy way to remember the electromagnetic spectrum order from lowest energy to highest energy is that red Martians invade Venus using X-ray guns. So radio, microwave, infrared, visible light, ultraviolet, X-ray, and then gamma. So let's talk about light behavior. Light travels in straight lines until it collides with an object or medium, which makes sense, right? All objects travel in straight lines until a force acts upon them. So until something impedes the light's path, it's going to continue traveling straight. So, and a medium is the object that a wave travels through. So when light collides with an object or medium, it can reflect, observe, transmit, or refract. Four things it can do: reflect, absorb, transmit, or refract. And we talked about transmission and reflection and transmission in previous unit with mechanical waves. One we did not talk about was refraction. So reflection occurs when light bounces off an object during collision. So it comes in, it bounces off the mirror, and bounces back. That's reflection. Absorption occurs when light enters a medium, does not travel out the other side. So occurs when light enters an object or medium, but does not travel out. When someone takes it in, but does not let it out the other side. And when we talk about colors, we'll talk about why we see white and black. Because white and black are not colors, actually. Transmission occurs when light travels through an object. So when either if all the light or part of light travels through the object, it is transmission. Refraction is the new one, and this occurs when light enters one medium from another and changes direction or bends. So it comes in and it bends in the medium. Let's say this here is water. The blue thing here is water. That would be when it enters in water, it bends. And maybe some of it gets reflected. But the more refraction is when light enters a medium and it bends or changes direction. And here's refraction up more close. Once again, it comes in and see, instead of going straight down, it bends. Alright, so ray diagrams. The incident ray is a ray that comes in. that's the initial light produced by a light source. Reflected ray is the ray that collides and bounces off the medium. Refracted is light that changes direction or bends when entering a new medium. And by Snell's law, the angle of the incident ray is equal or same as the angle of reflection. And this is what refraction looks like. So here light comes in on the first picture and it bends. And if you're in a swimming pool, because light bends, the observer seeing outside the pool will see the person's head detached from the body. Because the light comes in and it bends. And therefore it changes direction and makes it look like the person is actually in a different position than they're actually in. And once again, this is incident ray, reflected ray, and refracted ray. And we'll talk more about these later on. But this week, we just want to get an introduction into what light is, the electromagnetic spectrum, and then, of course, light behavior. And next week, we're going to talk about color, which is really fun and exciting.